A hearty welcome to respected jury members and all my viewers. Today we take this opportunity to share our minor project with you all. It may be the greatest of all human blessings, but it is surely a curse for those who lose their loved one. Out of all the deaths, 85% were due to heart attack and stroke in pre-COVID era. In view of this, we have worked upon our minor project to reduce the number of heart attacks by predicting them well in advance and taking the required treatment to avoid a stroke. So the title of our project is Heart Attack Predicting Using Big Data Analytics. I am Shahid, accompanied by Siddhartha and Virendra, going to share our project with you. Into the abstract. As we discussed earlier, heart attack is one among the deadliest diseases patients face. The key of heart attack management is to judge a lot of data, compare and mine to predict, prevent, manage and treat chronic diseases like heart attack. This system will discover and extract hidden data related to heart condition and therefore assist healthcare individuals to form intelligent clinical sections that traditional call support systems cannot. Big data analytics used in controlling different and managing giant data set may be applied with a lot of success to prediction, prevention, management, and treatment of heart attack. Big data mining, visualization, and Hadoop are technologies or tools of big data in mining the large data set for information.
Let me continue with the introduction. There are currently several researchers who have developed machine learning approaches for early detection of chronic diseases. The wearable devices deliver lightweight, reliable, low cost, and light health monitoring systems in healthcare areas. Thanks to several medical awareness initiatives, the constant tracking of changes in the body using smart sensors became a lifestyle. It also facilitates the treatments based on advanced diagnosis for human diseases by providing recommendation systems-based machine learning methods. The world is currently experiencing the era of IT, which relies on modern satellite communication systems and information systems related to electronic computers. And there is no doubt that many of the rapid changes that have produced many challenges for these organizations, so that they must move towards the application of IT to enhance its position. As competition and challenges facing towards organizations have become increasingly intense, the role of information in governance needs to be taken into consideration, prompting the organizations to accelerate the development of management, IT systems, and computer-based information systems. The use of modern information technologies, which have made a remarkable change in management in various functions, is no longer the precision of an administrative information system, is the decisive factor in the success of organizations and achieve the competitive advantage only. But there are many of the aspects to be taken into consideration, most important indicators for the success of MIS. Coming to the aim of our project, the aim is to identify the usage of big data analytics in heart attack prediction and prevention and management of the same. The use of the technologies is applicable to big data, privacy concerns for the patients, and the challenges and the future trends, as well as suggestions for the further use of technologies. The project domain is as follows. Many researchers are developing new approaches and technologies for using big data machine learning algorithms to prevent health issues at a very early stage of diseases. Big data analytics is changing the way we experience, provide, and receive healthcare. As more and more data becomes available through EHR, which means electronic health records, medication refill records, insurance reports, genomics, telemedicine, and more currently sensor data, we assume that innovators will design even more exciting ideas for using big data and really mining these technologies. As we can see, the process of data analytics in the flowchart given below, the first step is acquisition, followed by pre-processing, and then integration, followed by analysis and interpretation of the results and communication of the results. The applying algorithm is the interface between the input and the output Input is the data and some linked individuals, and the output is the predicted results which are communicated to the user. Scope of the project is the automation of the system would be extremely advantageous. Therefore, a medical diagnosis system like heart attack prediction system would probably be exceedingly beneficial. The model is efficient enough to predict the heart attack in prior and allow to take extra precautions to avoid the attack based on the values of the features. The accuracy of this model is to be moderate, as too much of accuracy could lead for overfitting problem. These are the literature review. This is the literature review, like what work has been previously done by the researchers in the same domain of which we are working at. Coming to the project description, the existing system mainly contains of, several separate methods for determining heart failure, which were tested and developed. One of the original works enforced the different data mining approaches along with the different parameters and health conditions. The precision of the number of parameters added is to be decided by the user, hence it doesn't work well with the large data set. Since KNN is a distance-based algorithm, the cost of calculating the distance between a new point and each existing point is very high, which in turn degrades the performance of an algorithm. It is sensitive to the outliers and missing values. Like KNN is sensitive to the outliers, and hence we need to first impute the missing values and get rid of the outliers before applying the KNN algorithm. Coming to the proposed system, we use hyperparameter optimization, which increases the accuracy of prediction along with getting the better results. Hyperparameters are important because they directly control the behavior of the training algorithm and have a significant impact on the performance of the model to be trained. Efficiently search the space of possible hyperparameters. Easy to manage a large set of experiments with the hyperparameter tuning. Our project has the following feasibilities. Economical feasibility. Once a break-even analysis is developed, the entrepreneurs can develop a realistic financial projections for the best case and worst case scenarios. In our heart attack predicting system, the project is economically feasible. That is, a cost-efficient system which can be worthy by any of the middle-class families as well as high-end families. Technical feasibilities. The first step in feasibility stage is technical feasibility. It also provides a visual means to share our concept with others. In predicting the heart attack using big data analytics, the purpose of the model is to communicate the final result whether the person will be attacked with a heart attack or not. Coming to the social feasibility of our project, it describes the effect on users from the introduction of the new system, considering whether there will be a need for retraining the workforce or not. In predicting the heart attack using big data analytics, the results are communicated socially and seek the acceptance from the society regarding the release of our model into the market. The system specifications of our project are as follows. Coming to the hardware specifications, we use the device Lenovo Yoga 7 with a processor of Ryzen 7. Installed RAM is about 8 GB, 8 gigabytes. System type is 64 operating system, 64 base processor. And the software specification, we use Google Colab as an interface for using the Python and install libraries in Python like scikit-learn and PyTorch, etc. Install dataset of the machine and which is to be needed to upload in Colab. The standards and policies, Google Colab, we are using Python 3.8 version, which is using Google Colab. Google Colab is a free open source distribution of Python languages for scientific computing. This aims to simplify the package management and deployment. Jupyter is another source which we are using, which is an open source web application that allows us to share and create documents which contains the live code, equations, visualizations, and text. Coming to the methodology, the general architecture of the system is as follows. The Hadoop distribution file system, also known as HDFS, is Hadoop's storage layer, which is housed in basically two layers, two data sets. heart disease dataset 1 and 2. And then this dataset is loaded into the framework, Hadoop framework. Hadoop framework has two modules, HDFS and HBase interface storage. HDFS in turn has two more modules. One is data name data node, and the other one is data node data. And finally, after the processing, the predicted output is given to the user side. Mainly replicated 3 times with the default. Each block contains 128 megabytes of data. Replications operate under 2 rules. 2 identical blocks cannot be placed on the same data node. When a cluster is break awake, all the replicas of the block cannot be placed on the same rack. The data flow diagram. In the heart attack prediction system, initially the patient data is taken and cleaned. After cleaning the data, unstructured data is changed into structured data. Then the structured data is then transformed using data transformations. Then the transformed data is sent for the modeling with the help of minimum support output is predicted. A use case diagram is basically a graphical depiction of the user's possible interactions with the system. In our model, initially the patient is required to give all the essential details to the system, which is used to predict the output, whether the person is attacked by a heart attack or not. As you can see in the figure mentioned, the patient gives the information like age, cholesterol, dress, BPS, chest pain, gender, TAL, CA, and the system after modeling predicts the output and communicates the same to the patient back. Coming to the class diagram, in general, class diagram is in UML indicates the type of static structure diagram that describes the structure of the model. In our proposed model, the patient model requires details like username and password and has an operations such as give the input, view report. And coming to the system class, also known as admin class, it also contains attributes like username and password, which has operations like test cases, analysis, and send report to the patient. The sequence diagram, as you can see, in general shows the process in form of interactions and time sequence and field of engineering. Coming to the patient side, the details such as age, gender, cholesterol, dress, BPS, chest pain, etc. are given to the system or the model. The system, which is trained, predicts the output based on its experiences and finally gives it to the patient. Activity diagram, as you can see in the figure, is a kind of flow chart or which is used to describe the dynamic aspects of the system. It basically represents the flow, or simply a flow chart represents the flow from one activity to another activity. In the model, initially the Persian data is fed up into the system along with the outputs. Then the data extracted is used to perform analysis, and the matching process is done to map the symptoms to the features. Then the classification of data is taking place, and the output is predicted based on the training from the model's experience. This is the algorithm. Algorithm is nothing but a step-by-step approach to solve the problem, and these are the step-by-step approach to solve our model, and followed by pseudocode. Pseudocode is something. Stop. Coming to the module description, the first module of our model is data pre-processing, which contains mainly 4 phases. The first one is cleaning. The first step in data pre-processing is that of cleaning the data. The data which we are going to work may not be the cleanest ones. That is, it may contain some missing values which result in degrading the performance of the model. For the purpose of avoiding this, cleaning is important. The missing values are either filled or removed based on certain strategies. The process of removing the noise is data cleaning. It is followed by transformation. In this step, the format of the data is changed from one format to another format, which is understandable by applying scaling, normalization, aggregation, smoothing like techniques. Integration. Integration is considered to be one of the most important tasks in data pre-processing, as data collected may not be from a single source, so it must be well integrated so as to avoid any problems while processing. The last one is reduction. The data which we are working on may not be a simple one. If the data we are working on is of a complex type, then converting it into a simple one which is quite understandable to the system by reducing them to the required format to achieve the results. These are all the features of our data set. Among this, we will be using the 13 best features for modeling of our model. The next module is data wrangling. Data wrangling is a method of cleaning and unifying untidy and complicated data sets for simple access and analysis. With the quantity of information and different sources quickly growing and increasing, it's obtaining more and more essential for big amounts of obtainable data to be organized for analysis. The next step is modeling. In this module, model is trained with two different algorithms with hyperparameter optimization for getting better results and accuracy. Coming to the steps to execute and run the program, the first one is data insights, drawing out the interesting inferences from the data to derive meaningful and required information. It is followed by exploratory data analysis, which is nothing but the analysis of data and drawing some more insights. The feature engineering step is done after getting the insights from the data, which we have to alter the features so we can move forward to the modeling phase. The final is model building. In this phase, we will be building our machine learning models, the heart attack detection. Coming to the implementation and testing chapter, the input design, the input to the model is a data set which contains a lot of information, which helps in deciding the value of the target variable, which is predicting whether a person will be attacked with a heart attack or not. The output of the system would be a binary value of 1 or 0, 1 for true and 0 for false, which predicts whether the person would be attacked by a heart attack or not. These are all the types of testing which we are using: the unit testing, integration testing, along with the output snapshots. This is the test results, the feature analysis, and coming to the efficiency of the proposed model compared to that of the existing model. In the existing model, a decision tree algorithm predicts whether to sorry, cut that. In existing system, a decision tree predicts whether the patient is attacked with a heart attack or not. It can easily overfit the data set and doesn't know whether it's crossed the line at a validation stage. And the accuracy is less when compared to the present model as well. In the proposed system, KNN is one of the algorithms used in the proposed model along with the random forest algorithm. KNN along with the hyperparameter optimization is the most popular one and improves the accuracy as well. For the feature selection, the used technique is particle swan optimization, which is computationally inexpensive and converges quickly. The results obtained show that algorithms perform well with good percent of accuracy with PSO as feature selection. Coming to the conclusion, a heart attack prediction system using big data solution was what we tried to develop. The proposed solution uses the big data architecture for the feature extraction and predictive modeling. The proposed model predicts whether or not the patient gets attacked by a heart attack or not, based on the values of the features. What can be done in future is what we are looking at. The current model which we worked predicts whether the person gets attacked by a heart attack or not, which can be scaled to a larger extent and use it to predict other clinical risks as well. This is a poster, and let's go to the execution part. Let us look at the code execution part. This is the code blocks of our code. And the first step is we need to import the data set, which is required to the data set is present in the minor folder. And the section name. The hard CSV file is to be imported. Yeah, you can see here the file has been imported, and then we need to run the modules. The first step is importing the necessary libraries which are required. Pandas, NumPy, Matplotlib for visualization, Seaborn also for graph plots, scikit-learn metrics for accuracy, pre-processing for processing modules, and so on. And the second step is data loading. We need to load the data. And yeah, as you can see, this is the data which we have been loaded into the data variable. And then we are doing the exploratory data analysis, which is nothing but just analyzing the data sets. Then we perform the individual feature analysis. The first one is age analysis, which analyzes which draws the insights from the age feature. And then this is what we get as the output after doing it. And now let's check the range of the age data set. So the minimum age of the data set is 29, whereas the maximum is 77. The mean, which is the average age, is between 54.3. And then we divide the age into 3 parts: young, middle, and young, elder. We just divide in the criteria. And then we just divide on rule that if age is greater than 29 and lesser than 40, comes in the young age, and the middle falls between greater than 40 and less than 55, and the elder or older age comes after anything above 55, and this is what we get as an output. After age analysis, we just perform the visualization for the heart disease, like for getting how much percentage of people are suffering from heart diseases. We get this as the result of 51.2% of older age people are being suffered by heart attacks, followed by 43.4% of middle-aged people and 5.4% of young-age people. And then we follow the same trend for remaining features as well. We perform the individual feature analysis of each feature. This is what we get if we run these modules. After performing the, let's run all the modules. After performing the individual feature analysis of each feature, we just go to the modeling step, like we just get the graph plots of each feature, and then we perform feature engineering, which is nothing but getting some new features from the old features. And this is feature engineering, which we perform, and then we just come to the modeling phase of our model, which we train our model with the training data, and we mainly use two algorithms here, KNN and random forest classifier. So this is what we get if we train you with KNN. The accuracy score of our model is about 85%. Otherwise, also not 0.85. To be precise. And after performing the hyperparameter optimization, the accuracy of our model increases with the K value of 19. We are getting the highest test accuracy at 89%. Also can be called as otherwise 0.89. So we achieved an accuracy of 89% with KNN after hyperparameter optimization. The comment to the second algorithm, when we perform random forest classifier, we initially get an accuracy of 83%, and with the hyperparameter optimization, we don't get any improvement in accuracy. Hence, hyperparameter optimization doesn't really benefit our random forest algorithm. And then this is we are fitting the algorithm, like we are training our data sets using a random forest classifier. It does take a little bit time, and in this way we predict the output, whether the whether the person is attacked by a heart attack or not, which can be quite useful in getting to know in advance what a person getting the heart attack or not in future, and taking the required treatment necessary. Thanks.